We are about to understand the topic of shell sort. In shell sort, the process is very simple. We also have to learn the algorithm. That's why I am showing the step along with algorithm. But the process of shell sort doesn't require you to follow the algorithm. If you observe it properly, then you can easily solve the problems of shell sort. At first, I will show you the problem with algorithm. Then we can proceed the general way how to solve it. So at start, we have 12 elements. Here, n holds 12. Now, once the process starts, let's see what happens. So we observe what happened. This n is divided by 2 as we can see, and the value of k is updated as 6 around here. It will continue greater than 0 and k again divided by 2 after few steps. If you want to truly understand this algorithm, during this short video I am not going to cover all the steps unnecessarily, but if you want you can put the values like me in this algorithm and you can get the algorithmic feel of this problem. So now we have k is equal to 6. Let's see next what happens. 61 and 24, and we can observe what actually happened. Just see, 61 is in the first position and 24 is according to the sixth position in this array. Just count here: 0, 1, 2, 3, 4, 5, 6. So this number is important. Now what happened here? I is equal to k. That means k is right now 6. You again, I am telling you, don't bother about the algorithm. Just simply understand the concept and you can easily solve it. Next, once you enter this loop, we find out AI. AI means a sixth position. So right now it is temp 6, which gives us 24. I hope it is clear now. Next, what happens? If temp less than a j minus k. So j starts from I. That means once you enter this loop, the value of j is officially 6. And after that, we are subtracting j minus k. Then it will gives you a zeroth position, which is officially the position of the 61 that we started. That is 61. And then what happens? There is a comparison. If temp is less than a zeroth position, as you can observe, temp is 24 here and a zeroth position is 61. If that thing happened, then there is an exchange of position among them, and that exactly is happening right now. Now we don't need to bother about this algorithm. This algorithm is very simple. I just show you the step what actually happening. Now we learn the process. Now shell get executed, and what is going to happen next based on this algorithm? There are certain arrangement you have to follow. You can see that this thing is keeping sixth place towards the right side. How to maintain that thing? Just observe here this thing, this k. That means you start j in ith position, continue it j greater than equal to kth position, and j will get decremented. So applying that into this logic, and again comparison takes place in that way. Next what happening? Next the comparison happen between location 2 with location, I hope it is 0, 1, 2, 3, 4, 5, 6, 7. So the comparison takes place between second place and seventh place. What we are actually doing, skipping this, that means we are shifting 6 step from here. There is an arrangement of 6. We have to move maintaining a gap of 6 between them. That is actually happening. Just observe. 190 is greater than 109. So we have to flip the position. Now ignore the algorithm and just observe what is happening step by step. Again 122 and 149. Same thing happened again among them. But observe, there is no swapping happened around here. Why? Because this condition is not satisfied right now. 125 and 111, in the previous cases what is happening, the temp is, or 111 in the previous cases, these are not maintaining this condition. The condition is 111 is lower than 125. So this arrangement of shifting doesn't require. That's why it will left as it is. Next 34 and 27. 27 is lower, so the exchange takes place. Again you can see 2 and 145. So we hope you understand what actually happened. Now we can see again this again part executed around here, this section. Here we can see k again divided by 2, and that's what going to happen around here. And now observe, we are moving this, maintaining a gap of 3 elements among them. Now see what happens. Comparison, swapping, again swapping, again swapping, and the same thing is repeated once again. But that's not the end around here. Now we can observe at this particular step there is another arrangement we have to maintain. If we move a little bit backward direction, 149, 122, 125, 111, 34, 111. Once the position changed, now there are two passes. How the passes maintained? In this algorithm, the loop is maintaining the passes. At the very beginning, based on the loop value, we have only one pass. But right now, in the second step, when k becomes 3, if at the end a swapping takes place, then we have to return back in the left side, maintaining 3 steps gap among them, and have to perform the same operation once again. Just observe. Again, same operation, but in left side we are moving. And if swapping happens, then only we move forward. Otherwise, we stop execution. Swapping takes place, so we again move and no further swapping is there. Next, we move to the last part again. Why we move to the last part? Because a swapping takes place. If there is no swapping, then we are not going to move in that direction. Observe. Now we have to stop and the loop of k stopped right now. Why? Because in that particular step there is no swapping takes place, and that's why we again dividing k existing value 3 with 2, and the process continue again. Now k will become 1 around here, and we are comparing element one by one because there is only one gaps between them. Now observe, as we are in the final steps, when the value of k becomes 1, we are performing the comparison. If you check once again, when k becomes 1, 24 and 27, there is no exchange of position. But in 27 and 2, there is a position of exchange. That's why in that particular step, that is the last one, where again you have to move in the left side to perform this operation. And again there is an exchange of position. Next here, then move here, change take place. Then again it will check in the forward. Why? Because once there is a swapping, it will check in the forward direction. Because there is no swapping, so we move to the next point, maintaining a gap of 1. There is a change. So once again forward. If no change, then the next element will be compared. Again forward. No change. Oh, there is a change. So again forward. No change. Now move to the next part. Again next part. Change. So it will go forward. No change. Then next part. Again it will go forward. Again it will go forward. And in the last part. So this is the entire process, and now we can see all the elements are being sorted. So this is the algorithm, and this is actually the C procedure I am showing you. You can apply this in case of algorithm. You can also memorize this entire coding. There may be a possibility for coding in your exam. For cell shot, the code is very small. After that, there is a complexity part. And it's very simple, that doesn't require much explanation around here, so I skip that part. But if you still want to see, or if you want to understand, the concept is there are iterations, and in each iteration in algorithm there is a certain gap we have to maintain. As the arrays are getting sorted, what we have to do, we are constantly maintaining certain repetitions based on some measured gaps between them. If we are about to perform a series of some calculation upon them, then we obtain some value like this. Due to lack of time and there is a lack of possibilities of coming complexity analysis in larger marks. So I suggest you to follow this, memorize this, because a detailed complexity analysis is not required for shell shock.